All right, let's take a look at a couple examples of how we use or how we can do prime factorization with certain numbers. Okay, and so we're going to start with the number 104, and I'm going to show you a bit of an easier technique, or one that might be a little bit quicker to solve than tree or prime. It's doing the same thing, but it's just kind of going through in a bit of a smaller way and maybe a little bit easier. So when you do 104, sorry, I'm going to do equal sign there, not a colon. Okay, 104, breaking into the prime factorization, what we can do, and this is using your calculator to its ability here, is we're going to start with 104 and we're going to divide it by a prime number. Okay, so we're trying to figure out what are factors of 104. So a prime number here could be 2. 2 works, okay, because it's an even number, and so we get that 2 is a prime number. But now we're not going to write down what it equals, okay, when we divide, but I will put that just on top, just as a reference guide. Okay, so I'm going to put it on top because 2 times 52 gave us 104, and then we're going to keep on moving. So 52 is also divisible by 2 as it's even. Okay, so that is 2 again, and that gives us 26. And again, this is just our reference. This is our actual prime factorization. Okay, bring that back there. Okay, so it's 2 times 2 times 26 would be the same as 104. Now we do 26. We can divide that by 2 again because it's even. Okay, and we get 13. And now we have to try to divide 13 by a prime number, and you may notice that 13 is a prime number. So if we divide it by 13, we get 1, and that's where we always want to stop. Okay, so 13, and we get to 1. Okay, and 1 is always our endpoint. So 104, okay, is the same as 2 times 2 times 2 times 13, or there's 3 of them, so 2 cubed times 13 would be the same as 104. Now we can do all sorts of numbers here. I'm going to do all 3 of these examples in the same video and try to get through it somewhat quickly here. And you can kind of follow along. So 630, now there's a number of different ones that we could start with, but I like to always start with 2 as it's a nice even number. So if we divide by 2, we get 315. Okay. Now notice that 315 is not divisible by 2, but we can divide it by 5. So we get 5 there, gives us 63. Now 63, not divisible by 2, not divisible by 5, but it is divisible by 3. Okay, so that gives us 21. Now what you may notice as well is that I put the number here just in case we make a mistake. So I'm just going to quickly go back. Let's say 63, we're like, oh, does it divide by 4? It's like, oh, no, it doesn't. But it's like, oh, what was our original number? Well, we go back to 63. So that's why I say it's a reference there. All right, so we were at 21. We can divide that by 3 again. And that gives us 7. 7 is a prime number, so we're going to put it there, and we get to 1. And so 630 is 2 times 3 squared times 5 times 7. And that would be our final answer right there. I'll just put a little square around there. I'll do the same thing around the previous one. Okay, just so we know what our final answer is. Now again, this works as well, that one there, but this is definitely going to be our final answer there. All right, let's do one more here. 2772. 2772. All right, now, once those numbers get a little bigger, it becomes a little bit more of a challenge. Okay, but again, even number, divide by 2. Okay, if we have evens, we might as well start with that. 1386, there's my reference. Okay, even again, so we divide by 2 again. 693. Okay, now this one's not even, so we have to divide by something else. And you know what? 3 is our next number, so let's try it. Let's see if that works. It does. Perfect. Okay, 231. Let's try 3 again. Again, not even. Works again. Gives us 77. Well, we're getting a little smaller. It might be a little bit more obvious which works. But let's say we try 3 again. Does not work. Well, we got to go back to 77. Let's try 5. Doesn't work. Let's try 7. Oh, sure enough, it works. That gives us 11. And again, we know that 11 is a prime number, so we put 11 in there at the end. That means that 2772 is equal to 2 squared times 3 squared times 7 times 11. And that will be our product of primes.